If there is anything you're going to maybe have a hard time with in section 2.8, it is these different quotient problems. It's something you haven't seen before, and sometimes it feels like it's confusing to students, just the notation, the way it's written. Now, what we've got, what do you guys know f of x as? It's just a fancy name for y, right? This over here is just a different y. So we've got y2 minus y1. Now if I look here at h, what do I have? I have a second x minus an x. Really, it's just a fancy way of finding the rate of change, or we know that is slope. But it's written in such a way that overwhelms us for whatever reason. So if there was anything to pay attention to in this lesson, this is the part. You don't need to get all crazy on their diagram here, but this will be given to you in your homework. It's not something you have to have memorized, but we do need to know how to use it. Okay, here's f of x, right? But then it also says that I need to have f of x plus h. And so I usually take a minute, and I'm just going to figure out what f with x plus h is. So I'm going to take a minute, and I'm going to simplify that. So here's my function. I'm going to have negative x plus h squared plus, there's another x, so I'm going to have an x plus h minus 9. Any questions with how I set that up? All we did was substitute it in, right? And now let's clean it up. A couple places where this problem could get you in trouble is forgetting that negative out front, and then forgetting how do we square x plus h. You've got to times it by itself. Remember, you cannot distribute an exponent. So we haven't even started setting up our difference quotient yet. We're still working on simplifying f of x plus h. So that would be what? X squared plus 2hx plus h squared plus x plus h minus 9. But then I've got to distribute that negative, which is negative x squared minus 2hx minus h squared plus h, x plus h minus 9. Are there any like terms there? No like terms. Sometimes there are. In this case, no like terms to combine. So that whole thing right there is our f of x plus h. So now we're going to set up our difference quotient. What does it say to do first? F of x plus h. All right, so here it is. Plus x plus h minus 9. Thank you for letting me know we were out of the camera. And then what does it say to do? Subtract f of x. So everything that follows that subtract, if you wanted to flip that as you write it down, that's okay. And then this is all over what? H. Now we have the fun job of cleaning this up. So, I heard some giggles. This is huge, I know. I've got a negative x squared. Don't I have a plus h squared there? So those go away. The x's go away. And the 9's go away. So this whole thing is gone.
Yeah, how do the x's go?
Ah, okay, good question. So I had a plus x, and then I had minus a positive x. So we distribute that negative in our head, and I shouldn't have done that.
Oh, it's okay.
I apologize. So now I am left with, slow on up for a second so you can get your notes going. I've got negative 2hx. I'm going to put minus h squared in front just because sometimes I like to have things in descending order. Plus h all over h. Any questions to that point? Yeah, we're going to reduce that h out of everything now. Yeah. So that would be what? Negative h minus 2x plus 1. That's it. Yay, that's it. This is some of the most serious pre-calculus you guys have had yet. This will be a big part of your calculus career in the future. So, this isn't going away. Let's try it with this one. I'm going to let you guys set it up a little bit more. I'm going to slow up on this side. Let's make sure that you can kind of figure out what we've got going on. Remember, the first thing we did was we've got to figure out what our function is with x plus h in it, substituting that in. This one's a little friendlier, maybe? I don't know. 1 over, what's going to go there? X plus h, and then minus 6? Is there anything to clean up there? No, there's really not. That was way nice until this next part. I know. So now we've got to set up our difference quotient, right? We're going to set this up. So I have my f of x plus h, this cute little thing we just did. And then it says minus what? F of x, which is this little thing. And that whole thing is what?
Oh.
It's the fractions, right? It wasn't necessarily the algebra that's going to get us in trouble, but it's the fractions. And I do need to simplify this. So, that being said, how do I add and subtract fractions? What do I have to have? I have to have a common denominator, right? So that means I need to multiply this one by x minus 6. And I need to multiply this one by x plus h minus 6. Alright. So then we have what? Our common denominator is x minus 6 over x plus h minus 6. And in our numerator, we have x minus 6. Now remember, that's a negative 1 that we're going to distribute right now. So we have what? Negative x minus h plus 6. And this is all over h. Did you see anything as we were writing that down? That goes away. That goes away. And now we have negative h over this fun stuff. Now a little trick I like to do, just because it makes things feel better, and you don't have to do this, but as soon as I do that, and remind you that we're dividing by a fraction, even though it's just h, okay? How do we divide by a fraction? What do? We times by the reciprocal. So we're going to now times this by 1 over h. So flipping times, right? And now what happens? Our h's cancel. And we are left with negative 1 over x minus 6, x plus 6, h plus 6 minus 6. Goodness gracious. Read it, don't listen to my words. And so not only was it challenging, it leaves us with an ugly answer. So we're never 100% positive if we did it right until you type it in and it says, good job. That's what it's going to say every time. It's going to tell you, good job, right? Because you're going to watch all of your signs. You'll be fine. Oh, I'll leave that there for a second before we go to the next page. Those are a little overwhelming, but they're going to be okay. Oh, that's calculus. That is beautiful calculus right there. You will see more and more as you take your next class. Function notation. I'm going to go ahead and assume that this is mostly review. I'll go through it quickly. You can just stop me if you have a question, okay? Remember, this is where we did f plus g of x, f minus g, f times, oh, and we've got fog and goff. All right, so let's remind you the secret shortcuts. When it's written this way, do not figure out what w of u is. Do this. Plug 3 into u, get that number, and then we're going to plug that number into w. So start on the inside. It says plug 3 into u, which is right here. 2 times 3 minus 2 is 4. Now we're going to take that 4 and we're going to plug it into w. Negative 2, 4 squared, minus 2, 16, negative 32, negative 34? Yeah. Thank you. I was questioning myself. Now, these two problems mean the exact same thing. This is w of u of 3. This is just different notation. W of u of 3. Would you like to see me do another one of those? Because I would be happy to. Feeling all right? So on this one, we'd go into the w first, and then we would plug it into the u. All right. No question? Oh, these are kind of fun too. This is, I can't remember if we did this in Math 3 or not. I feel like we didn't. I've got some function, and they are going to give you some crazy, wild-looking functions. And it's a combination of functions, and our job is to pull it apart into its pieces. What do you guys see here that could be our different pieces? I've got that guy, right? And then don't I have something raised to the 6th? So if one of my functions, one of them is v, one of them is f, one of them is g. So if one of my functions is the obvious one right there, f of x plus 6, the other one, g of x, would be what? Something raised to the 6th, x raised to the 6th. Now, which way Oh, I don't need to worry about it. Neither function can be the identity function. I thought we were going to have to figure out which way was f. Oh, we do. I don't know if this one's f or if this one's g. We've got to figure that out. I know those are my two functions. I shouldn't have written that down yet. I've got to figure out which is which to make it line up that way. Which one is plugged into the other? Which one is the inside function?
G.
This one? Isn't f of x plus 6 inside? Right? Notice I'm covering up the f and g. I shouldn't have written those yet. I shouldn't have made that decision because I didn't. I just wrote them down haphazardly, absent-mindedly. I don't know which one's f. I don't know which one's g. Would you guys agree f 5x plus 6 is inside, right? It's inside parentheses and it's being raised to the 6th. So this is my inner function. Which one's the inner function here? So this one has to be g, and this one has to be f. I got ahead of myself. Sorry about that. Oh, that was composition of functions, and now it's composition of functions advanced. Wow. All right. For the real valued functions, got g of x and h of x. Find the composition g of h and specify its domain using interval notation. So it's telling us we need to substitute h into g. All right. So that would be, I'm using this guy, putting that in there. So I've got a 2x minus 9 plus 2. And then I have a 2x minus 9 plus 3. Well, let's simplify that. I have a 2x minus 7 over 2x minus 6. Is anybody tempted to reduce that fraction? We are so tempted, but don't do it. Remember, they've all got to divide by the same thing. So 7 won't let us reduce this at all. Now, our domain of g of h is limited a couple ways. It's limited by what we can put in there, and it's also limited by our end function. So if I look at 2x minus 9, are there any values that don't exist for x when we're graphing a straight line? I can put in any number for x and find a y value on a linear function, right? But you do, so check the inner functions domain. And then check the ending function. Two places we need to look. What can x not equal on this one?
3.
Yeah, so 2x minus 6 cannot equal 0. 2x cannot equal 6, so x cannot equal 3. How do we write that in interval notation? It's been a minute. If 3 is the only excluded thing, isn't that what it looks like? Okay, there was more new in that section than there is in the next one. I'm hoping between our Math 2 and our Math 3 classes that this Section 3.1 stuff will come crashing back. We are talking about things like vertex form. And we were graphing by using vertex form last week. We will talk about minimums and maximums, the axis of symmetry, x-intercepts and y-intercepts. Those are all key features? You bet. I would be happy to. Right there? I'm going back, sorry. Just because it's kind of hidden in here, I want to remind you to find the axis of symmetry. We use x equals negative b over 2a. And it's been a long time since we've done this. So that, I can't remember if it's on your formula sheet or not. We'll have to look. Is it okay if it's in the page? Graph the parabola. We graphed from this form last week, and we just used transformations, right? What does a plus 2 do to your parabola? Up 2, that plus 5 moves it. All right, so left 5, up 2. Our leading coefficient is 1. So if we go over 1, what's 1 squared? 1. If we go over 2, what's 2 squared? 4. Vertex form is amazing. We love it. Today, they're not always going to be in vertex form, and they'll kind of force you to find some of the key features. Okay, on this one, some basic questions. Is it open, upward or downward? Down. Down. Find the vertex. Over 3, down 3? All right. Find the x-intercepts. None. Find the y-intercepts. Is that negative 7? 2, 4, is it negative 7? All right. And the equation for the axis of symmetry. Remember, that is where we have that parabola balanced. And you can't just type in 3. Yep, because it wants the equation, it has to be x equals 3. Any questions on that one? Good. All right, graph the parabola. And it is not in vertex form. So these are our steps. Find the axis of symmetry. We will use x equals negative b over 2a. So in this case, that is what? X equals, up here, negative 8 over 2 times negative 2, which is 8 divided by negative 4 is negative 2. So we've got x equals negative 2. Now, you do not need to graph the axis of symmetry in ALEX. The reason we find that is so now we can find the vertex. Okay, we do need to be able to plot the vertex. So find the vertex by substituting the axis of symmetry value into our function. if we do y equals, I've got a -2. What was our value that we got? -2. All right. So -2 squared minus 8 times -2 minus 5. -8 plus 16 minus 5 gives us 3. So our vertex is, the x value is -2, the y value is 3. -2, 1, 2, 3. Now substitute in values for x. And remember, we can always reflect it on the other side because a parabola is symmetric. What's one of the easiest numbers we can plug in?
Yeah.
Let's plug in 0. All right, so we've got our x and y. If we plug in 0, y is -5? Yes, sir.
Can you also
Absolutely.
say that x squared is -2?
Absolutely. You can do your transformation that way too.
Did you guys already do that?
No. I'm glad you brought it up because that's where I was going to go next. So 0, -5, and I'll point out what William was just talking about. And I can reflect that on the other side. It was 2 away. If it's asking me to plot 5 points, I need to do 2 more, don't I? The further I get away x-wise from that vertex, the more likely your points are to be off of your chart. So I might choose to plug in -1. So let's see, we've got -2 times -1 squared minus 8 times -1 minus 5. -2 plus 8 minus 5 is 1. So we've got -1, 1, and reflected on the other side. And I love that we've graphed enough parabolas that several of you are noticing, hey, once I find that vertex, can I look at that a value right there? The negative makes it open downward, and then over 1, 1 squared is 1, but times it by our 2. So over 1 down 2, put me right there. All right. And then over 2, 2 squared is 4, times it by that guy. What is that? 8, down 8. Both methods work wonderfully. Thanks for bringing it up, William. Who has caught on to that and that's what they like to use? Just curious. Good. Love it. Can I turn the page? Nobody's protesting. Okay. Maximum or minimum when I've got a positive function? Oh, this is what a max looks like. And this is what a minimum looks like. So it's a positive function, so it makes us want to say maximum. But what do we have? We definitely have a minimum. Ooh, what is the function's minimum or maximum value? Alex is going to be rude, and it's going to trade these back and forth. They want to make sure that you know which one reflects the x and which one reflects the y. To find this one, guess what we have to solve for? I mean, all it's essentially asking is we need to be able to work with the vertex. That's what we're looking for when it's saying max and min. So if I want to know the x value of our minimum, we're going to use x equals negative b over 2a. All right, so we've got a negative 4 over 2 times 2, which is 1. There's our x value. What is the function's minimum value? It's a fancy way for saying, what's the y? It's really all it's asking. What is the y? How do we find the y? We're going to substitute in 1. Yep. So 2 times, there's my 1, 1 squared minus 4 times. I don't know why it's so much fun to see it in color, but it is. 2 minus 4 minus 2 is, what's your shortcut?
So with the difference quotient,
Ah,
you can,
oh, hold on to that. We'll talk about that in a minute. Okay. I hope it works on all of them for you. Okay. Now, they give you lots of words in this problem. Lots and lots and lots and lots of words. Jump over them and look at this. What's it asking for? It's asking for the minimum, which is a fancy way for asking for what? We're looking for the vertex, right? That's all we're looking for. So if it's saying what is the minimum cost, we might have to look back through here. C is cost. So I'm going to need to end up finding the C, or the y value. That's ultimately what we're going to be needing to look for. So to find the y value, what do I have to know? I've got to know the x. We're just going to use x equals negative b over 2a. These, you're going to get ugly answers. You just are. I know. So negative 104 over 2 times 0.4. What'd I lose? Did I lose something?
should there be a negative on 0.4?
Negative, I did my negative b, and I changed the sign on that one.
Oh, okay, yeah.
All right, I see some of you with your calculators out. If you'll tell me what you get, I would love that. Just 130? All right, so there's my x value. To get my y value, what are we going to do? 0.4, 130 squared. Aren't you grateful they let us use calculators?
Yeah.
Me too. Plus 11,799. Who's typing that thing in?
Not it.
Not it. I'll grab mine. Oh, where is my yellow calculator? There it is. So we've got 0.4 times 130 squared minus 104 times 130 plus 11,799. Oh, it's not so ugly. $5,039. This X-ray machine needs to cost at least $5,000 for them to start making money. Okay. I am actually, just for the sake of time, going to skip over this one. If it's asking for maximum area, what is it looking for? Maximums and minimums, we're always looking for we're just looking for the vertex, okay? So I'll skip over that one. I do want to do this one. We didn't cover this very much last year. I want the equation of that parabola. This is where I like to use this form because it gives me the vertex.
His computer did shut off
midway through.
And you just had to log back
I
in?
logged it back in, so
Perfect.
I don't know if that shows on your.
Nope, that will be great.
Okay.
Thank you. Here's our vertex form because it gives me the vertex. Our vertex is the h and k, right? All right, y equals a x minus a negative 5 plus 2. All right, I was feeling really good about it until I realized I don't have my a. Any ideas on how we find that a? It's dumb, that's what you said.
2. Look at the graph.
We could look at the graph. Is this an x and a y over here? So could I plug in x and y and solve for my a? That's what we have to do. Okay, and that's what I wanted to remind you of. So our y value is 10. We don't know the a. Our x is negative 7 plus 5 squared plus 2. I'm just going to move my 2 over here right now. 8 equals negative 2 squared is 4a. Questions with how I got there? So a is 2. Remember, it wanted the equation of our parabola. So there's our a. X minus our h squared plus our k. Lots and lots and lots today.